Let's talk about how to classify triangles by their side lengths and by their angle measures. We're going to start out with a warm-up because you've actually learned a lot of this before in middle school, but in high school geometry we're going to kick it up a notch. In our warm-up we're just going to start with the basics. Take a second to see if you can take the words from the word bank on the right and apply them to each of the 7 triangles that you see on the left. Pause the video and try it now. Let's see how you did. If a triangle has 3 congruent sides, we call it equilateral. Equa, of course, means equal, and lat actually means side, so it's equal sides. 2 congruent sides is isosceles, and no congruent sides is scalene. The angles, I think, are the easiest names to give out because if it has 3 acute angles, it must be an acute triangle. If all 3 of the angles are the same, then it must be equiangular. If one of the angles is right, then it must be right, and if one of the angles is obtuse, then it must be obtuse. So classifying by the angles is pretty straightforward. We just have a couple of strange words to remember for your side lengths. 2 congruent sides means isosceles, and no congruent sides, all 3 sides being different lengths, that means it's scalene. The technical definitions for each of these classifications is if it's an acute triangle, then all of the angles measure less than 90. If it's a right triangle, then one of the angles measures 90. If it's obtuse, then one of the angles measures greater than 90. And if it's equiangular, then all of the angles are equal, which we'll discuss later on means that all of the angles measure 60 degrees. Equilateral triangles have sides that are all 3 of them are the same length. Isosceles has 2 sides that are the same length, and scalene means that no sides are the same length. So for every triangle you can give it 2 classifications, one for its angles and one for its sides. So let's look at a few examples where I ask you to classify triangles. You're going to give me 2 answers, one for the angles and one for the sides. Here's triangle ABC, and I see that angle B is marked as a right angle, so that means that this triangle must be a right triangle. But I don't see anything labeled about the sides. None of the sides are labeled as being congruent. Therefore we assume that this is scalene. So I would classify triangle ABC as being right and scalene. Or scalene and right. It doesn't matter what order you write those words in. Triangle DEF has all 3 angles marked as congruent and all 3 sides marked as congruent, so we call this equilateral and equiangular. Triangle GHI has 2 sides marked as congruent, but not the third. So not all 3 sides are the same, only 2 of them are, and that makes it isosceles. We're not told anything about the angles, but you are allowed to assume obtuse versus acute. Angle G and angle H both appear to be less than 90 degrees, so they're both acute, but angle I is greater than 90 degrees, so that makes it obtuse. Triangle JKL, we're really not told anything at all, it's just a triangle. None of the sides are marked as congruent, so I would call that scalene, and all 3 angles appear to be less than 90 degrees, but none of them are marked as congruent to each other. So I would just classify this as acute because all 3 angles are less than 90, and scalene because none of the sides are marked as congruent. Now let's talk about how to describe different parts of a triangle. We've seen before that in order to name a triangle, you have to write a triangle symbol and then the name of each of the vertices in any order that you want to. So for example, this triangle could be called triangle XYZ. Each of the sides of the triangle gets a special name depending on which vertex you're referencing. Vertex, remember, is just another name for like a corner. So X is one of the vertices of this triangle, a vertex of this triangle, because it's one of the corners. So let's say, for example, that we were talking specifically about angle Z. In relationship to angle Z, sides XZ and YZ are adjacent sides, because they're the 2 sides that make that vertex, that make that angle. And side XY would be the opposite side, because it's on the other side of the triangle from angle Z. The sides that are opposite and adjacent will change based on which angle it is that you're talking about. These 2 are the adjacent sides, and this is the opposite side only if you're talking about angle Z. It would change if you were talking about angle X. For angle X, side XY and XZ are adjacent to angle X, and side YZ would be opposite. And the same idea for angle Y. YX and YZ are adjacent to angle Y, and XZ would be opposite. For right triangles, we get special names for our opposite and adjacent sides in relationship to the right angle. The two sides that create the right angle are called the legs of the triangle. So RI and TI would be the legs of this triangle, because those are the sides that make the right angle. And the side across from the right angle, the one that doesn't create it, is called the hypotenuse. Now, unlike what we said on the previous slide about adjacent and opposite sides being relative to whichever vertex you're talking about, with right triangles, you only call the side across from the right angle the hypotenuse, and only the sides that create the right angle are called legs. You would never, for example, call side IT the hypotenuse, even if you're talking about angle R. Angle R is not the right angle. It doesn't matter which angle you're looking at, I is always the right angle. You could say that side IT is opposite from angle R, and that sides RI and RT are adjacent to angle R, but no matter what you're talking about with this right triangle, this is the right angle, so these are the legs, and this is the hypotenuse. Isosceles triangles also get special names for some of their sides. The sides that are congruent to each other are called the legs. So IO and SO are the legs of this triangle because they're the ones that are marked as congruent. And side IS would have to be the base of this triangle because it's the one that's not congruent to the others. A common misconception is that the base is the side that the triangle sits on. And as you can see here, that's not necessarily the case. Because triangles can be rotated and reflected and all that fun stuff that we saw in our transformations chapter, the base isn't always going to be the side that it sits on. Instead, the base is the side that's not congruent to the other two. So let's look at a few examples and identify what part of a triangle we're looking at. Number 1, BD is the something of triangle ABD. Well, triangle ABD is this one, the entire triangle. So I'm going to kind of forget about C and this right angle inside of the triangle. I really just want to focus on the whole thing. BD is this side. Now looking at triangle ABD, it's isosceles because it has two congruent sides. And BD is the side that's not congruent to the other two, so we would call that a base. What about AD in triangle ACD? Well, triangle ACD is just this one on the right, so I can kind of ignore the stuff on the left for right now. Triangle ACD is a right triangle. And side AD is the side that is across from the right angle, across from angle C. We call that the hypotenuse. What about sides CA and CB in triangle ABC? So this time I'm just focusing on the triangle on the left. And we actually kind of lost some information when we got rid of the right-hand triangle over here. This was a right angle, so this would actually be a right angle as well. So I'm going to go ahead and write that on there. CA and CB. So these two sides right here, well, I would call those legs because they are the sides that create the right angle. Okay, what about AB and AD? Again, just focusing on the big triangle because it says triangle ABD, so it's the whole thing. I really don't need C here or the right angle inside of the triangle. Triangle ABD is isosceles, and the two sides that are in question, side AB and side AD, are the two sides that are congruent to each other. So we call those legs as well. So you'll notice we actually have two different things that are called legs for triangles. It depends on what kind of triangle you're looking at. If you're looking at an isosceles triangle like this one, the legs are the ones that are congruent to each other. And if you're looking at a right triangle like this one, the legs are the sides that created the right angle. And last but not least, which side is opposite from vertex A in triangle ABD? Well, again, I'm just going to focus on the big triangle, and the side opposite from angle A would be side BD, which, as we said earlier, is also called the base. So that's the basics of what you need to know about classifying and describing the parts of triangles. In our next lesson, we're going to learn about the triangle sum theorem and the corollary to the triangle sum theorem.